Okay, so now we're going to be working on part 4. Part 4 is very similar to part 3, except we're going to just put everything inside a for loop and then make it run 1,000 times. So what you need to do is, first of all, we're going to create a random number, say ending in the last 4 digits of your phone number. So you basically just need a 4-digit number to set your seating. So that should be the first line. Then we're going to create a for loop that is going to have everything that we had before. So what you just need to do is just basically copy and paste everything that you had for your previous part. Except that now what we're going to change, okay, so now once you've pasted everything, we're just going to go around the things that we need to change and what we need to loop. So the first thing that you need to do is to put a for loop in the outside, and this is going to allow us to loop 1,000 times over our simulation. So basically we're going to run the simulation 1,000 times. This may take a little bit of time, so if your computer is a little slow, I would just copy and paste this not into a live script but into a normal script, and this is hopefully gonna make you like debugging a lot faster and the plotting a lot easier. So at the end you can just copy and paste it back into your live script, but for the beginning you can do it in a normal script. So if we just loop 1,000 times, we're gonna say for I, where am I? Okay. So for I equals to 1, and then we're going to go all the way up to 2,000. This is going to ensure that we're going to run our code 1,000 times. And then just don't forget to put n to close that loop. So what is nice to do most of the times is if you have for loops and then inside other loops, I would like indent everything that's in the other loop so you don't get confused on what is ending where. So for example, this while loop is inside this for loop, and then this if statement is inside the while loop. So let me just do that real quick so that we don't get confused. Okay, this now is inside the else statement, and this end is closing our if statement, and then this end is closing our while loop. So here's our while. Okay, so if we go to the for question set the random seed to be at least 4 digits, so that's what we've done, and then do 1,000 stochastic simulation. You just get that by doing for loop, and then collect the final values of C. So basically we don't want to plot anymore. We don't want to plot because this would result in 2,000 plots, so we definitely don't want to do that. Get rid of all your plots. Okay, and it says that what we want is the final value of C. So in order to do that, in order to get that last value of C, what we're just going to do is we're going to create like an NC saving variable. And of course, since we're going to save it every time you finish a simulation, so you want it right before that end word for your for loop. And then since you're going to be creating one every single time you loop around, you definitely want to put that I inside. Now, since your simulation is just doing point by point, you get the last value of C just by saying Z. So if you want to understand this a little more, I would definitely encourage you to copy and paste this code into a script and then just run it one by one, and then you'll see how things change. So at a particular time, there's only one value for S, one value for C, and one value for the time. So when you do this while loop, you're not saving your S's, you're not saving your C's, but it's being updated every time. And that's why for part 3, we were plotting here every time because we're plotting 1 point at a time. So in order to get your last value of your C, that's just going to be the last point. So you just call it NZ, I equals C, and that should be it. However, there's a little thing that you have to do, and it's that if we look at part 4, they said it says collect the final values of C in a vector and discard all the cases with final C equal to 0. So basically every time that the zombies lost and then zombies became equal to 0, we have to discard that number. For that, there's just a little Matlab trick. Let's see, we have an NC vector that has 1, 4, 0, 7, 8, 9, then another 0, then 5, 6, and then another 0. So we have this vector here, and we want to get rid of all the zeros and then keep all the other numbers. So this is the notation that you want to have. So you have nz, right? Now you open parentheses and you give it the condition you want to get rid of. So you say nz equal to 0. Basically that's telling Matlab everything that is 0, and then I want you to put it in like a trash vector. So that's what this is going to be doing. It's going to get rid of all your zeros and it's going to save everything else. So if we run this piece of code here and now we say nz, we see that we cropped out the 0 here, and then it goes 1, 4, 7, and then we cropped out the other 0 here after the 9, and then the last 0. So now we only have all the numbers that are different from 0. So you want to put the same line of code right after your end function, and then so you just do nc and then blah 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 blah. You get rid of all those zeros, and then the last thing you have to do is plot it as a histogram. So in order to plot it as a histogram, just make sure you clear your figures, and then you can just use the histogram function in Matlab. To get it, you just say histogram, and then you'll see that it first asks you for an x value. So basically, what variable are you plotting? We're of course plotting nz, so you type nz. Then let's go back here. Then it says n bins. Then it says, okay, so first you put your variables, which is nz. Then it says n bin, which is how many bins you want. So to complete this part, you need a range. So basically how we've been doing our vectors before, in the case we say, so we want 10 bins between 100 and 210. So we're just going to say start at 100, then give me exactly 10 bins, and then when do you want it to end. So if I'm not wrong, your PDF asks for 220, so you can just type the end. And that goes inside this histogram right after your function. So you look at here, you have x, again, nz, and then n bins, which is written like that, 110, and then 200, 220, whatever your PDF asks for. And that goes in n bins, and we don't have any options. That part here already makes the plot. So then the next thing that you have to do is put your x labels and your y labels and then your title. He's also asking you to find the mean. To find the mean, you can just use, again, the Matlab built-in function called mean. So you can just say, okay, mean is equal to, and then make it, and then it's just mean of your variable. So whatever your variable is. In our case, it's nz. So that's the variable you want to find the mean of. So that's what you do. You put it at the end, and then just don't put the semicolon because you want to output that value. That's all you have to do for part 4. It's really easy. Just make sure you get rid of your plots, otherwise you're going to get a ton of plots. The other thing that you have to change is just add this for loop, and I think that's all you have to do. Make sure you're making this nz and make sure you're getting rid of those zeros. That's all you want to do. And then for the end, you're only plotting the histogram. So you're finding all these nz's, but it's only to plot the histogram. And your histogram should look something like this. Your mu, which I call mu is my median, it's about 162.9, 163. It's going to vary, I think, slightly depending on what number you used to see it, but it should be around this value. You should see this kind of bell-shaped curve around 160. So I hope this helps, and I'm very happy to be your TA this semester, and I hope your final goes very well.